Hi again, everybody. Welcome to my next video. That's me. I have there we go. So if you're wondering what I look like, that's my floating head. Alright, so let's get started. I'm going to do some videos on energy, and I think we're just going to start with what I call the energy spiderweb map. And it's just sort of a layout to give you some perspective. Energy, like many things, is a word we use often. You know, when you talk to people, you know, it's one of the fun things about teaching physics. You know, when you talk to people and you start to, and it's not even about physics, it's just about learning in general. When you talk to people about what they know or think they know, you can ask people, you know, if you walk down the street and say, how many people know what a brick is, right? So yeah, a brick, I got it, yeah, a brick of, you know, red brick, stone brick, gold brick, right? You ask people, you know, it's a word we use, it's a thing we know, right? You ask people what energy is. Do you know what energy is? Yeah, most people say, yeah, maybe, and maybe they won't, but man, whether you know what it is or you don't know what it is or you think you know what it is, you use the word all the time. So we have some idea what we think it is, and one of the hardest things about learning is figuring out what we know and what we don't know, and how true our understanding is, and also the context of that understanding was applied to. Because when we say I'm going to work, we don't mean the same thing we mean in physics. In fact, when we say in the real world, when we say the word hypothesis, that has a very different meaning. Or actually, when we say the word theory, that has a very different meaning colloquially in the real world in our day-to-day life than it does in a scientific perspective. So let's just start with some things. Work, energy, these are words that we often see together, and we can look them up and we can hear people tell us stuff, and inevitably when we ask about work or energy we get some sort of equation or a bunch of things. So first thing I'd like you to do whenever you're watching something like this, we're talking about a topic, is to ask yourself, you know, what do you think these things are? If you've had any experience with physics, you probably have some idea that you've seen these words before. If not, focus mostly on energy and ask yourself, what do you think energy is? It's a weird question. There's a bunch of these words we use that are often difficult to define. So how do we do that? How do we define them? So what I want to do here is really just talk about I'll say the complexities, but the types of ways that we express energy and sort of map it out, but not really get too far into it. So I'm just going to put a big old E in the center. E for energy. And then we can start going off, and there's different paths. So if you're in a general physics arena, you come over here, and the first thing you learn about really is what's called mechanical energy. Can't believe I'm going to write this all out. I'm going to try and be, careful with my writing. My handwriting kind of sucks a lot, but you know, just listen along. And I abbreviate a lot, so I wanted to write ME for mechanical energy. But mechanical energy, there's kinetic, you know, and there might be what people call potential energy. And I went through a phase where I just hated on potential energy constantly. It's like, it's not real, it's not really real. Anyway, it bothered me, so I never used it because it didn't really make sense to me to use it. I didn't need it, but I found purpose after years of playing with it, reasons to use it. And in potential energy, you may have come across, there's gravitational potential energy is the most common. Things like MGH, you know, and there's like a G, M over R minus, you know, just some equations, but we're not really worried about equations. There's potential energy, and that can be gravity. And we'll get to that in a while in terms of there's a potential energy associated with gravity. There's near the Earth, and there's two interacting bodies, there's configurations, and sometimes we use spring potential energy, which really bothers me some of the time, but again, depends on the depth, but we'll come back to that. In kinetic, there's translational, and there's rotational, you know, for starters. And again, this isn't intended to go into minutia and detail, but just to get an idea. And the way this is always introduced is oftentimes with work, which can be branched into conservative work non-conservative work, network, right? These words get thrown around in textbooks. And most of this stuff is associated with some sort of equation. And we learn how to manipulate the equations, but we don't necessarily know what they mean or how they actually relate to the physical world. And this is one of the big deals for me. Everything we do needs to relate to the physical world, which means I need to be able to make a diagram or a drawing that can connect me to it. And we'll sort of see that as I build videos. I love nothing more than to be able to say, here's a real situation, you know, a bicycle. You know, it's a really oversimplified idea. Just a guy on a bike, but this is a real thing, and what we're trying to do is abstract away from this to an equation, right? Unfortunately. But in between here and here is a lot of sort of sub-steps that allow us to understand the abstraction and the connection between the equation and the physical world. So I want to kind of avoid those. But no pun intended here, but this feels very mechanical, equation-based. And we're going to dig deeper into this. This will be the first thing I talk about. Then we get into these other types of energy, and I'm just going to call, for funsies, internal energies. And that would be related to a system, but we don't really have to talk about what that is right now. But I mean, these internal energies can include things like thermal energy, which might be related to temperature, which is not energy. It's related to energy. And we might have chemical potential energy. I hate calling it potential energy, so it's just chemical energy. And we'll talk about why I do that when we talk about potential energy, when we get back to this. There's also nuclear, right? And then there's probably some others that I'm not really bringing in here. And these are sort of things that are interesting. Bonds between atoms, the things that hold the nucleus together. These are forms of energy that are valuable to us. And endothermic and exothermic reactions, right? We can get heat, cool, nuclear stuff. Obviously, we can get power, energy, things like that. But there's also these radiant things, waves. They can carry energy as well. Sound, if you can hear something, that's energy leaving, right? Some system. You can have light, other forms of electromagnetic radiation that can bring energy into or out of a system. And then we can get into the really fun stuff, right, where we always joke about, you know, in these general physics ideas, well, there's all this stuff, but then we can really just sort of knock it all down to a very simplified idea. It's not really simplified, we'll say less parts, perhaps, that everything can always be written in some way. So we've all seen this, right, E equals mc squared. But it really looks like this. And you're like, what? No. This is actually, in special relativity, the total energy. It includes kinetic energy and an energy called rest energy, the rest mass, which is what m0 is. And that's the energy associated with the matter, essentially the mass of the object. And then snuck in here, by way of this gamma, is the kinetic energy. So this basically is telling us that there's really only kinetic energy and mass, and it, you know, that's how we can sort of interpret that, and we'll come back to this. But I think the point I'm trying to make here is that there are bits and pieces, and depending on which way you go, the need for depth, the necessity for understanding might vary. The amount of understanding may vary. It can vary from situation to situation. One of the things that's really neat in physics is that concepts apply to situations. Situations don't apply to concepts. We're trying to describe things, and we do that by creating things that we define. Energy is not a thing that exists. It's how we define the world around us, right? We name these things. For example, light. You know, we hear a lot about light and particles and waves, and there's this, you know, is light a particle or is it a wave? And the reality is it's not. It's light. A wave and particle are things we made up to describe the behavior of certain things. Some things are grouped into the wave category. They can be diffracted and reflected and, you know, And there's particles, and they do, they can travel through space, and they don't need a medium to travel in, and there's these rules that we can come up with. And if something fits these rules, we call it a wave or a particle. And if something doesn't fit either of these rules, or fits both of the rules, then we have different problems. So light is light, and understanding with our tools leads to some, I don't want to say wiggle room, but some interesting outcomes. So all things worth talking about. But right now I'm going to focus on energy. So, just to get a basic idea of what energy is, you want to say what it is, and you don't want to use words that are difficult to say. So one of the things I like to say is, what questions can you ask, to understand it. You ask what is it, maybe you ask what it isn't, or how it works, or what it does. So we can think of things like actions, right? Is energy an action? Do you do energy, or is it something you have? Right? And there's neat ways to sort of, as we always talk about spending energy, and there's a really neat analogy. Like, if you think about money, everyone loves money. We all want to have a lot of money, but we also spend money and we earn money. And these are things we do to either reduce what we have, right, or gain more or have more, right? So these are like actions, right? And if we think about that, energy ends up being something we have. I've run out of energy. I've run out of money, right? I need more energy. I need more money. I do something to change that, and the two basic ways we do that are through processes, and these processes are work and heat, right? You can't have either of these. You do work, right, on an object, and you heat an object. I put it on the stove, I heat it, right? It's heating up, and when you heat it, you're giving it more energy. If you cool it, you're taking energy out. This is that whole idea in some context. So what we're going to do is we're going to try and explore energy, and just for fun try and make sense of it. And I'm going to start with mechanical energy. So in my next video I'm going to discuss mechanical energy, and I don't know, see where it goes. This is one of those fun things I do randomly on a Tuesday night. So if, again, at any point you're watching a video and you want to ask a question, feel free to pop me a note. I'm happy to respond or make videos. I like to learn, and I find questions are the best. We never go a semester without getting a question we've never heard before. It's awesome. So hope this is helpful, informative, or whatever, just for fun. I'll see you the next time.